Welcome student. Myself Sanjib Chatterjee on behalf of Chatterjee Academy. So I will give a short lecture on the vector product and projectile motion. Okay. So for vector, as you know that we have two parts, right? Scalar and vector. So vector means having both magnitude and direction. So scalar, we don't have those things like mass. Mass is a scalar quantity, only is having the magnitude. So vector quantity is starting from displacement. So displacement is a vector quantity. Then the next will be the velocity, then acceleration, then force. So these are the vector quantities. Now you can see here, work is a scalar quantity. So you will understand how does work will be a scalar quantity. Okay. So similarly there are other product vector. Those are scalar. So even product of a vector is also becoming a scalar product, right? So you will see that the different product of vector, how they are coming, scalar or product, scalar or how you can say the vectors. Okay. Now let's see that. Okay. Let's see. Now let's a vector. How we are defining a vector? A vector A is ax I cap, ay j cap, and az k cap. So this is a vector, and what are the rectangular component of this vector? One is ax, another is ay, another is az. So three components we have for these vectors, right? So now what happened over there? So if I say draw x, y, z, this is x axis, y axis, z axis. So along x axis the unit vector is I cap, along y axis unit vector is j cap, along z axis unit vector is k cap. Okay. So I, j, k, these are we are saying orthogonal triad. This will be we are saying orthogonal triad. Okay. So that means so ax I, this is a vector along x axis whose magnitude is x, unit vector is I. Then ay j, this is a component vector, rectangular component. Ay is along the y axis and this unit vector is j. Similarly this one az component is along the z axis. Okay. So these are the three. Now if you say it's a two-dimensional vector, so it will be like a vector is equal to ax I cap, then ay j cap, ij. So this is a two-dimensional vector. Now what will be the magnitude of the vector? So magnitude of the vector A is ax square plus ay square. If it is a three-dimensional vector, then A will be ax square, ay square, az square. So this will be the magnitudes. Now what is the unit vector? Let's say I have the A vector. So magnitude, unit vector of A will be, if I take n cap, means A vector divide magnitude of this vector. Okay. This way we can able to get the unit vector. Okay. Now let's. Okay, I'm facing some difficulty removing. Okay. Now let's go to the other part of the vectors. Okay. Now what is the product of the vectors? Scalar product and the vector product. Okay. So there we are having the three product of vectors, right? sorry, two products, scalar and vector. Let's write the scalar product. So it will be A vector dot B vector is equal to AB cos theta. So this is called the scalar product. Okay. Let's say A vector and say B vector, and angle between them is theta. So the product of these two vectors will be A vector dot B vector will be equal to AB cos theta. AB cos theta. Similarly, if I take the dot product, cross product, then A vector cross B vector will be AB sin theta n cap. If you see this, so this resultant vector will be along the perpendicular direction of this plane A and B. Okay, so this will be the cross product. So cross product will always be a vector, but dot product will be a scalar. Okay. Now let's calculate the unit vector multiplication. Let's say let's take I vector dot I vector. So it will be 1 dot 1 cos 0 degree. So 1. Similarly, J vector dot J vector is equal to 1 dot 1 cos 0 degree 1. So I vector and I vector, these two are the parallel vectors. So parallel vector, the dot product will be 1. Similarly, J and J unit parallel vector, their dot product will be 1. They are similar vector, right? Similarly, K dot K will be 1. Now, if I take I dot J, it will be 1 into cos 90 degree, it will be 0. Because I and J are perpendicular, right? I vector and J vector are perpendicular. Similarly, if I take J dot K, it will be again 1 dot 1. So angle between them is 90 degree, right? So it will be 0. Okay. So dot product of the other like Ij, Jk, these are all be the 0 vector. I mean that product will be 0. Okay. Now we'll see the similar thing in the cross product. What is going to happen? So for cross product, let's say this is A cross B is equal to AB sin theta, then n cap. AB sin theta n cap. Then what's happening? It's happening that let's say I vector cross I vector is equal to 1 into 1 into sin 0 degree n cap. So sin 0 degree is 0, so it will be 0. So I cross I is 0. Similarly, I cross J will be sin 90 degree, right? Ijk, it will be K vector. So I cross J means 1 into sin 90 degree, and perpendicular direction means we are taking K. So this will be Kk. Okay. So this way, these are the pattern of the cross product. Or you can see the similar vector cross product will be 0, and the vector like I, J, Jk, there will be having the values like, if I take I cross J, it will be K, right? Then J cross K, it will be I vector. Fine. Okay. So this way, next class I will show you the vector product, like we'll take the real vectors and we'll do the the dot and cross products. Okay, let's say I'll give you a force vector like fxi, fyj, plus fzk, and force and s displacement vector is like sxi sy j then szk. Then if I take the work, it will be f vector dot s vector. So it will be the scalar output. It will be like fx sx plus fy sy plus fz sz. Okay. So next class I will be showing you the details of the product of vector and scalar. So till now, thanks for watching this video. So just wait for my next class. Okay. Thank you.